Hello everyone, this is Mrs. Telemann, and today's lesson is on the importance of using significant figures in the science lab. The first question to answer is why? Why is it that we need to use significant figures? Well, in your physical science class, you will use measurement tools to collect data during lab work. Your results will depend on the measurement tool you use and its precision. Precision refers to how detailed or exact a measurement is. It all really depends on the measurement tool you use. In other words, in the specific digital scale you use to measure mass, or the triple beam balance you use, or the graduated cylinder you use to measure volume of a liquid, or any other measurement tool you use. It really depends on how precise that particular measurement tool is. Let's say you're measuring the mass of a rock using two different digital scales. Here we have two digital scales that a teacher may have bought for their class. The first one, digital scale number 1, is one that is precise to the thousandths of a gram. And this is a more expensive scale, $564 approximately. You will find this type of scale in more of a high school setting or even a college level class. The other scale we have here, scale number 2, is precise to the 10th of a gram. So it reads the mass up to the 10th of the gram only. This particular scale is $236, and this is a scale you will mostly find in the middle school lab. In our class, we will be using digital scale number 2. So let's say we wanted to find the mass of a rock. Okay, we have the same exact rock, but for using the first scale, let's say we obtain the mass to be 10.234 grams. If we were to use digital scale number 2, on the other hand, the mass would equal to 10.2 grams. You can see the difference here is the number of digits or significant figures the scale gives us for the measurement of that particular rock in grams. By looking at this, we can see that digital scale number 1 is much more precise than digital scale number 2. Now let's say that we needed to measure the volume of this rock. Obviously, we would use water displacement to find the volume of the rock using a graduated cylinder like the one seen here. So let's say after we do our water displacement, we find that the volume of the rock is 3.5 milliliters, which will then say that the volume of the rock is 3.5 cubic centimeters. If we had another graduated cylinder with much more precision, we may have found that the volume of the rock wasn't just 3.5, but rather maybe something like 3.5243 cubic centimeters. Again, if we have a different tool we use with more precision, then we may find that the numbers are different, like these two numbers here. One is 3.5 cubic centimeters and the other one is 3.5243 cubic centimeters. So now let's say we wanted to find the density of this rock. As we know from before, density of an object is the mass of the object divided by the volume of the object. So let's take the two different cases. Let's take the first one. Let's say that we used the mass of the first digital scale, and the mass was 10.234 grams. And we use the density, the volume of the more precise graduated cylinder, and our volume was 3.5243 cubic centimeters. When we plug this into the calculator, we get 2.903839 grams per cubic centimeters. Now, if we were to do the other calculation using the other measurements from the other tools we used, then we can say that the mass of the object, as shown from digital scale number 2, was 10.2 grams, and the volume of the object from the first graduated cylinder was 3.5 cubic centimeters. So this would give us a different answer, or at least a slightly different answer. When we plug the second operation into the calculator, I get 2.91428571 grams per cubic centimeters. So as you can see, we get slightly different numbers, especially once we start getting to the hundredths of a gram per cubic centimeters. We get different numbers according to the precision of the measurements we obtain from the different tools we used. You can see the difference between using tools that are more precise versus using tools that are less precise, meaning we only have the grams to the 10th of a gram here measured in this digital scale, as opposed to in this first digital scale here we have the grams measured to the thousandths of a gram. The mass is measured to the thousandths of a gram. So this one is more precise. We get different numbers. The second operation we did is a little bit less precise because we use different scales and different graduated cylinders, and we get a slightly different number. Those two numbers are different. They're different quantities. They're different results we would obtain in the lab. As you can see, precision plays a big role in why we need to use significant figures. And significant figures are important in order for us to get the right results or the correct results when we're conducting a lab. On these two quantities or measurements we obtained, we are not done completely because we still need to take into account the correct number of significant figures for a final answer. The first calculation, 10.234 grams divided by 3.5243 cubic centimeters, are limited to the number of significant figures each one of the original quantities gave us. So if we look at the first one here, we have 1, 2, 3, 4, 5 significant figures on our mass for the first calculation. Then for the volume we have 1, 2, 3, 4, 5 significant figures. Since they both have the same number of significant figures, according to the division rules using significant figures, we will go with the least number of significant figures for our final answer. In this case, they both have 5, so the final answer needs to be rounded to 5 significant figures. So we have 1, 2, 3, 4, 5. We don't need to round up because it's a 3 afterwards. So our final answer for this quantity would be 2.9038 grams per cubic centimeters. That would be the correct answer according to the numbers we had here to begin with from the tools and from the precision of the tools we used. When we look at the second problem we're using, 10.2 grams divided by 3.5, we have a different amount of significant figures from each quantity. 10.2 has 3 significant figures, and 3.5 has 2 significant figures. So according to the rules of division with significant figures, you have to go by the least number of significant figures in the operation. In this case, it would be 2. So our final answer needs to be rounded to 2 significant figures. In this case, it would be 2.9 and everything else would not be included. So our final answer for this problem would be 2.9 grams per cubic centimeters. As you can see, the numbers are completely different, or not completely, but very different than what we originally started with when we did the division. Here we have 2.9038 grams per cubic centimeters because they were limited by the number of significant figures given to us from the measurement tools we used. This one was even more limited because they only gave us 3 significant figures for the mass, 2 for the volume, limiting the quantity to 2.9 as the final result or answer. these two numbers are very different, and those give us different results when we are doing calculations in our labs. So to recap, significant figures are important because they are dependent upon the precision of the tools we use for finding the measurement of whatever mass, volume, density, etc. that we're using in the lab. So I hope this has helped in understanding why we need to use significant figures in the lab. In the future lessons, we will learn about the rules of significant figures, how to count which numbers are significant, as well as the rules for multiplying, dividing, adding, and subtracting with the correct number of significant figures. After viewing this video, I would like you to do a one-paragraph summary or more of why we have to use significant figures in the physical science lab. Why is it important, and what is the factor limiting the number of significant figures we use? Again, you need to write a one-paragraph summary describing the importance of the significant figures being used in the laboratory, and what effects or what limiting factors affect the number of significant figures we use. Thank you.